Hey guys, it's Miss Delcambre. Today's Thursday, April 1st, so happy April Fools. Yes, it is no joke that you are hearing from me, but also it is no joke that tomorrow we will have off, so you will not be getting one of these videos. So what we did today, we went over two of our questions for our mock star. Our builder needs to be turned in today. Builder 24 needs to be turned in for a grade today. We graded it in class. We went over our 17.4 notes video. We did an activity. I'm going to show you the data that we received on that activity. That's where the practice comes in. So you'll need pencil, pen, your journal, highlighter, and you need glue to glue in your notes. And the question for my online kids was, do you have bubblegum at your house? If you so, get a piece and don't chew it until you're told to do so. All right, so let's get going. Please make sure your builder is turned in. Please make sure your builder is turned in. It's builder 24, so please make sure that that gets done and turned in. Next thing I want to go over is the video where you can find that. I'm not going to play it. I did add it to the stream. It's a stem and leaf a la Schmoop. So it's about a 2-minute video, and it kind of gives you like a little preview of stem and leaf. So watch that probably after this video. It will kind of all sink in. So let's get started. Let me pull the notes down to the screen. Here we go. All right, so you have 2 pages of notes here. Okay, you have page 2 with histograms, but we're going to start off with page 1, which is stem and leaf. All right, so let me grab my highlighter and grab my pen, and I also need a pencil. So let me grab my pencil, grab my pen. Okay, and today again is 4/1/2021. And you can use stem and leaf plots to display numeric data. Each data value consists of a stem and a leaf. So each one consists of a stem and leaf. It's just another way to display data. Just like a box plot, just like a dot plot. It's the same thing, but in my class today, lots of my kids have said that stem and leaf plots are a lot easier to work with than box and whiskers plots or box plots. So we'll see how that works with you. Okay, so the first question here says, the 12 members of a high school basketball team have a free throw drill. Each player attempts 50 free throws. The number of free throws made by each player is given. So the first thing you always want to do is group your data. Make it in order it from least to greatest. So they've already put down some numbers, so I'm going to cross them off so I don't duplicate. So there's a 25, 2 29s, a 30, a 32, I see a 33, so I'm going to put 33 here, cross it off. I see 2 35, so I'm going to put 35 twice. I see a 36. It's all my 30s, and then here's 44. Okay, so put them all in order. Now I'm going to organize them into a stem and leaf plot. So with a stem and leaf plot, your stem talks about the tens position, is the tens position, and your leaves is the ones position. Okay, so if I'm looking at my stem and leaf, I have my stem is 1, my leaf is 9, because 9 is in the 1 spot. So that's it, because there's no other numbers that aren't in tens. So here we have 23, 25, 29, and 29. Okay, because you have 29 twice, you're going to put 2 9s down there. Okay, now I'm going to go to the stem of 3, which is my 30s group. So I have 30, so that's a 0. I have a 2, a 3, 2 5s, and a 6. And do you see how I don't put a comma between them, guys? I don't put a comma, so it just looks like that. And then 4 next to 4, because that makes 44. Okay. So here's our question. The number of home runs a baseball player hit in each season he played is shown in the stem and leaf. How many seasons are included in the stem and leaf plot? So if I look at my data right here, you can figure out, because we're talking about home runs, you can count the leaves because each leaf represents data. So each leaf represents a season he has played. And so that would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So 12 seasons this baseball player has played. And I did that by counting the leaves. Okay. That's a little light. Let me go grab another color real quick to kind of darken it up. Okay. Now, what was the least number of home runs the baseball player had in one season? So if I look, the least number is 0. So 0 is the least amount of home runs. 7742. If you didn't know, Miss Jackie's extension is 7742. 0 is the least amount of home runs. And we talked about this in class. Why 0 in one season? He could have scored 0 home runs. One person said he may have been in a batting slump. That's perfectly fine. That's a good thought. The one that we came up with was the most was that he had an injury, is why. Or you can think of here recently, COVID happened and it kind of halted all the sporting events. So they might have canceled the season. Kind of like baseball, they basically canceled it mostly. They kind of had a shortened season, and if they had a shortened season, he may have not have had any hits on those games. Okay? All right, so let's talk about histograms. Histograms is my next one. So again, today's 4/1/2021. A histogram is a type of bar graph whose bars represent, now I want you to talk about bars real quick. Their bars touch. Okay, their bars touch. So they're touching bars that represent frequencies. How many times? How many times of numeric data within intervals? How many times does something occur within these intervals? Okay, so here's our question. Here's our problem. A bird watcher counts and records a total number of birds at a bird feeder every morning from 9 on for several days. So there's all of his data. Okay, so we're going to make a frequency table. So divide it into equal size intervals of 4. So it's 0 to 4, 1 to 4, 5 to 8, 9 to 12, 13 to 16. So each one, there's 4 in between them. Okay, so divide the data into equal size intervals, make a frequency table. So there we go. My intervals is my X. My frequency is my Y. My intervals are my independent. My frequency is my independent. Is my dependent. Sorry, flip that around. Frequency is your independent. Your birds, your range is your range here. Your intervals, that's your intervals, is your independent. Your frequency of the amount that they occur are your dependent. Okay? So here they made a histogram. Do you see how each of the bars touched? So we have a question. Kim has started rating each movie she sees using a scale of 1 to 10 on an outline. Here are her ratings so far. Make a histogram of the data. What does the shape of the distribution tell you about Kim's ratings? So let's look real quick. Okay, so what I'm going to do is I'm going to take these ranges and I'm going to just write them down here at the bottom of my paper. And I'm going to do some tally marks. So I'm using this range to kind of give me a number so I don't have to count. Kind of maybe easier. It was easier for us to do it like this. Okay. So then I'm going to look at my data and I'm going to put a tally mark in whatever group that they're in. So I have 6. So that's one tally mark. A 9, another tally mark. I have an 8, a 5, a 7, a 4, another 8, another 8, a 3, a 7, an 8, a 7, a 5, a 1, and another 10. So now I have my tally marks. Now I'm just going to just kind of just write, okay, so that would be 1, movie that was there, 2, 3, 7, and 2. Okay, now I'm going to make a bar graph. So I had one movie that scored a 1 to a 2. So I'm going to come over here and I'm going to make my bar right there at 1. Put it there, kind of go over a little smooch it over. There we go. So made it right there at 1, and I kind of make sure my bar takes up the whole ratings in that interval section. Okay, my next one was 2 for 3 to 4. So my box is going to go up to 2 there for 3 to 4. And then I have 5 to 6. I'm just going to take this highlighter. And I had 3 from 5 to 6. Well, 3 is right about here. It's going to go right there. It's 5 to 6. All right, 7 and 8. Let me grab another color. Right here's a pink. And it went all the way up to 7. So I'm going to go bring this line all the way up to 7. There we go. And finally, 9 to 10 had 2. So do you see how my bars, well, they're all different colors to represent the different ratings that they had, the intervals of ratings. And I also did it where they're all touching because it's a range and they're all touching. So make a histogram. We already did that. Does the shape of the distribution tell you about Kim's ratings? So if we look, the shape, it's kind of goes skewed to the left, meaning that more data is on the right, meaning that she's giving more of a higher rating to over half of the movies that she's seen. So we can say that Kim has given a rating of 7 or better to over half the movies. Okay. All right. And that did it for our notes. And then we did our activity. And I want to talk to you about the activity. I'm going to show you the data that we got there. So why you needed bubblegum is because we did a timed bubblegum chewing activity. So students were given some bubblegum and they were asked to blow a bubble. And I've noticed that some students don't know how to blow bubbles. Not everybody did. Anyway, so what we did was we took that data. So let's look. Actually, we extended it. I first had it for 2 minutes, but I extended it and it was a 3-minute time. So they had to count how many times they blew a bubble within a 3-minute time period. So here's our data from our first hour. Okay, then we took our data and we put it in numerical order from least to greatest, and then we created a stem and leaf. Okay, our ranges were over here. So our 0 to 9, 10 to 19, 20 to 29, and 30 to 39. And this is going to help us when we make our frequency table down here. So this kind of goes along with our frequency table. And with this data, we were able to find the range. We were able to subtract the high and the low. We were able to find the median. Okay, we were able to cross off a high and a low each time and then got to the middle number, and it was 15. We found the mode. The mode was 10 bubbles, and the mean, we added them all up and divided by how many, and we got that the mean was 16.3. So with all this information in our stem and leaf plot, we are able to find all 4 measures of center. Now, with our frequency table down here, we did our frequency and we counted it in intervals of 2, so 2, 4, 6, 8, 10. Okay. My bottom, my x-axis was labeled bubbles, and this was my range of bubbles. So those who made 0 to 9, 10 to 19, 20 to 29, 30 to 39. Do you see how we made them all 10 apart? Okay. and then we graphed accordingly. So with that little piece of data that we did of just blowing bubbles, we were able to get 2 graphs, and we were able to find measures of center with it. So lots of people think it's better than the box plot, so let me know what you think. All right, so that does it for me today. Guys, have a wonderful weekend. You will not see me tomorrow, and that's no April Fools. Have a wonderful Easter. Stay safe. And Monday, we're going to be doing a project with categorical data. And if you bring some candy, please make sure you have some colorful Easter candy. Could be like M&Ms, robin's eggs, jelly beans. Not too many where you like have so much, not too less where you only have 2. So it needs to be kind of like different colors. All right. So that's what we're looking for Monday, because we're going to be using it to create some more data. All right. Have a safe Easter.
Go to your mom's room, please. Connor, go to your mom's room.
And if Connor, if you're watching this, you need to go to your mom's room. All right. Talk to you later. Bye.